Hi everyone, and welcome to Surface Area of Prisms and Cylinders. So let's start off with talking about what a polyhedron is. It's a three-dimensional figure that is formed by polygons in a region in space. So if we know that, we can now talk about what a prism is, which is a polyhedron with two congruent bases in parallel planes, and the lateral sides are rectangles. So here's a prism here on the right. You can see the two bases are congruent and in parallel planes. There are two base faces, there's four lateral faces. The vertices are where the lateral edges come together. So how do we find the surface area? Well, we just add up all of the areas of the individual sides. So it's the sum of the areas of all the faces, base and lateral. So let's try an example. Find the surface area of the prism to the right. So I recommend making a net so we can see all the sides. In this case, there's going to be 6. Let me color them here so we can match with the figure. So I have 3 different kinds of rectangles. So I've labeled 1, 2, 3. And I've labeled some of the key dimensions. So the area of the first section is length times width, which is going to be the smaller rectangle. And it's 10 times 4, which is 40 square centimeters. Area of the second one is the larger rectangle here. It's going to be 17 centimeters times 10, which is 170 square centimeters. And the last narrow yellow section here, length times width, we get 68 square centimeters. So the surface area is, we have to add up all 6 sides here. So we have 2 A1s plus 2 A2s plus 2 A3s. And we get 556 square centimeters, or centimeters squared. So the surface area is 556 centimeters squared. All right, let's try another one. So here we have another prism. The bases are right triangles, and the other 3 surfaces are rectangles. So I can make up another net here. And we're finding all the areas again. So this time we have to use the area of a triangle equation. And I'm going to call this area A1. And then we have 3 rectangle areas. So the area of the triangle is 1/2 base times height. So we have the base is 24 and the height is 7 inches. We get 84 square inches. Now the others are just straightforward length times width. So I've got A2 is 28 times 7, it's 196 square inches. A3 is our largest rectangle. It's a 28 by 25 rectangle. We do that, we get 700 square inches. And then the last one, A4, and this pink, it's a 28 by 24. We multiply those together. And then we're going to add all these up. Now there's 2 A2s, so that's why I say there's 2 A1s. And then the rest we just add. So 2 times 84 gives us the 2 triangles. And the rest we just add. So we get 1,736 square inches. Okay, let's talk about a cylinder. It's a solid with congruent circular bases that are in parallel planes, and the space between the circular bases, or the circles, is enclosed. And so we have a couple key dimensions here for a cylinder. We have the radius, r, and the height, h. So how do we find the surface area? So if r is the radius and h is the height, then the surface area is 2 pi r squared plus 2 pi r h. That's an equation. So how do we come up with that equation? So we're going to look at that here in a second. So let's try this in an example. See why this equation works. So I have a cylinder to the right, and I know the radius and the height are given, 4 and 12. I'm going to make a net. So we've done these before. We've got two circles and a rectangle. Now the A1 area is just a straightforward pi r squared. That's the area of a circle, and we get 16 pi units. Now the area of the rectangle is length times width. And the width is the same as the height, which we got as 12. But the length here is going to be the same as is the circumference of the circle, C. So that's 2 pi r. So the length of the rectangle is the same as the circumference of the circle. So we know the radius, so we can find the circumference, which gives us the length. So put it in, 2 pi r times h, and it's 2 pi times 4 times 12. We get 96 pi units squared. So we need two of these A1s, the circular areas, and one of the rectangle, and we get 128 pi units. So in the equation, let's look at it. We can break it down. We can see the two circles. We have 2 times pi r squared, and the 2 pi r is the circumference, which is the length, times the height, which is the width. Okay, example 4. The circumference of the base of a cylinder is 16 pi and the height is 21. Find the surface area of the cylinder. So I just drew a little cylinder here. We know the circumference is 16 pi and the height is 21. And so here's our equation. Surface area is 2 pi r squared plus 2 pi r h. So we know 2 pi r is 16 pi. That's the circumference. And we know h is 21. So we know the second part of the equation. We don't know the radius for the first part. So what can we do? We can use the circumference equation and find the radius. So I can substitute 2 pi r for c equals 16 pi and solve for r, and I get 8 units. Now I can take this 8 and put it into my surface area equation for r, and then simplify, and I have it first in terms of pi, 464 pi units squared, which is approximately 1,457.7 units squared. Okay, example 5. We're almost done. We have a couple more here. A floor has 600 square feet of area. What is the area in square inches? So we know there are 12 inches and 1 foot. So if we take 600 feet squared and we multiply it by the unit conversion, which in this case we want feet to cancel, so we would multiply by 12 inches over 1 foot. That would cancel feet, but doesn't cancel feet squared. So we have to square the unit conversion here so that the feet squared units cancel. So I get 600 feet squared times 144 inches squared over 1 foot squared. And that gives me 864,000 square inches. Let's do one more like this. A box has a surface area of 800,000 millimeters squared. What is the area of the box in square meters? So we know in 1 meter we have 100 centimeters. In 1 centimeter we have 10 millimeters. So in 1 meter we'll have 1,000 millimeters. So what we want to do is we want to take 800,000 millimeters squared and multiply it by the unit conversion 1 meter over 1,000 millimeters. But we need the millimeters squared to cancel. So we have to take this unit conversion here and square it. So we end up getting 800,000 millimeters squared times 1 meter squared over, now what's 1,000 squared? Well, it's 1,000,000 millimeters squared. The millimeters squared units cancel. And when I divide 800,000 by 1,000,000, I get 0.8 meters squared. Okay, everybody, that's it for this section. I hope it makes sense. I think you're ready for the practice set. See ya.